on this that the standard deviation is sigma squared, it should just be sigma. This one should be sigma squared. Call it an elderly moment or a blonde moment. Either way, it was a moment. Okay?
We all have moments.
Yeah.
But then would the solving be the same then?
Yeah, the solving, it's still solving it the same way. Let's go on to that problem we were looking at yesterday. Right here.
So do you take both totals together?
Nope. So you're going to take this total right here.
That's the squared total?
Yep, the squared total. So you're going to take the squared total, which is 128. Okay? So when we look at standard deviation or variance, it's going to be the sigma of xi minus mu squared divided by n. Okay? And that's actually down below in your notes. You can see it. But so this would be 128 divided by how many data points do we have? 10.
Wait, why is it 6 squared? Wait, how did you get 75?
Oh, this is not a 6. This is sigma. Sorry. Yep, sigma. All right, so this is going to be 128 divided by 10, which is 12.8. That is the variance. I think it's A and C, right? Okay, now if I wanted to find the standard deviation, then I'm going to take the square root of this. So the square root,
Wait, why would you take the square root of it?
yep, standard deviation is always the square root of the variance. Okay?
Why would you square it in the first place?
So the square root of 12.8 is 3.6. All right? Let's keep looking. Down below, whoops, I went too far because I wanted to show you guys this thing. This is all your formulas, okay? And this is for a population, and I need you guys to pay attention to this. Remember the difference between a population and a sample. Yep, population is the whole thing, sample is just a part, okay? In most statistics, do you take statistics of a whole population? No. So in this class, you're going to be focusing in on mostly this. Right here. Variance is standard deviation of a sample. On this one, over time, mathematicians have realized that when dealing with a sample, dividing by n minus 1, the total minus 1, instead of the total, provided a better estimate. When the data is a sample, Roman letters instead of Greek are used for the mean, where x with a bar on top is read as x bar, and the variance is just s squared, and the standard deviation is just s. So instead of the Greek letters that looked kind of funny before with the sigma, they use an s. Okay, a little easier. That's what you're going to be using. It's the same exact thing that we did before, except you're dividing by n minus 1. Yes?
So the S, wait, so the S is only used when we use sample?
Yep.
And then if we're doing population, we're actually using sigma?
Yep. So S is only used for sample, sigma is used for population. All right? Okay. So, like I said, this caution, word of caution, most of the book is doing a sample, okay, unless it tells you otherwise. Okay, so let's do another example here, and this is on a sample. According to the United States Department of Agriculture, 10 to 20 earthworms per cubic foot is a sign of healthy soil. Mr. Green checked the soil in his garden by digging 7 1-foot holes and counting each of the earthworms. He found the following: 4, 23, 15, 10, 8, 12, and 18. Calculate the sample variance and the sample standard deviation of the numbers of earthworms per cubic foot. Okay, so the first thing we got to do is what? What do we got to find first? The mean. Yay, good job.
Wait, so it's X bar.
It's X bar this time instead of mu. Okay, so we need to sum all these up. So that's going to be 4 plus 23 plus 15 plus 10 plus 8 plus 12 plus 18. Did you guys get 90?
Yeah.
Okay, so and then there's 7 data points, so we're going to divide that by 7. And that's 12.9. Okay, so remember X bar is our mean. Yep, 4 minus 12.9. So that would be negative 8.9. And then 23 minus 12.9. That'd be 10.1. And so on. So what I want you guys to do, oh, what is 8.9 squared? One of you guys have that? 79.21. Okay, so I'm going to pause this, and what I want you guys to do is fill in this chart. Okay, so this is what I have up here on the board. Okay? Hopefully you guys got something similar. So now the next thing I want to do is find the variance. And what I'm going to do is add up all the last column, first of all. So if I were to sum all that up, I'm going to have 245.07. That's the sum of that column. The rightmost column. Okay? So my variance then on this one, S squared, is going to be 245.07 divided by n minus 1.
Why is there an extra column?
An extra column?
Yeah.
Oh, I think if you wanted to put your sums down there, you could. Yeah. Extra row. Yep. So this is going to be divided by 7 minus 1, right? N minus 1. So 245.07 divided by 6, and you should get 40.8. That's the variance.
And then do you do the square root of 40.8?
Yep, so you're going to do the square root of 40.8.
Wait, that's not the right number. That's 245.
What'd you get?
I got 244.87.
Okay, it could be that I added it wrong. I'll double check on that in a minute. But, so, whatever the sum is supposed to be, you divide it by 6, and you should get something close to this. And then you're going to have the square root of that to find the standard deviation. Okay? And this, based on the 40.8, you should have a standard deviation of 6.4. But I just need to double check on that score. So, ladies and gentlemen, it is 244.87. This was incorrect. So my variance instead of this should have been, so this right here should have been 244.87. And if you take that and divide it by 6, it's not far off. Okay, 40.8. So it really didn't change it all that much. It's just by a couple decimal points. Okay?